Good evening, 7th grade, and welcome to Lesson 4-8 on exponents and division. In last night's lesson, we looked at exponents and multiplication. So now it's only right that we go through exponents and division. Our lesson tonight has two objectives. First, you're going to be able to divide expressions containing exponents. And secondly, you will be able to simplify expressions with integer exponents. Now, as a warm-up, they say write in simplest form. We've done these before. If I wanted to do number 1 here, I have x squared divided by x. Well, I can take a look, and I could really rewrite x squared as x times x divided by x. Right, and you see right away, oh, both of them have a factor of x. So you could cross out the factor of x on top and bottom and just be left with x. All right. If I go to number 3, however, it's a little different this time. We have 6 times x times y divided by 9 times y. This time we don't just have variables, we have coefficients in there too. So here you have to also divide or get rid of any number that both 6 and 9 have in common. So if I think about it, I know the factors of 6 are 1, 2, 3, and 6. The factors of 9 are 1, 3, and 9. Well, the factor they have in common is 3. And then I could divide that out and get 2 times x times y divided by 9 divided by 3 is 3y. And again, I could look for those variables they have in common, which is the y, and get 2x divided by 3. So that is something we've worked on in the past. Now we're going to move on a little bit. Well, we're going to move forward. So here it says solve using a calculator. We have 7 to the 7th power divided by 7 to the 3rd power. So if you pull out your calculator, 7 to the 7th power, and remember that really means 7 times 7 times 7 times 7 times 7 times 7 times 7, because we have 7 as a base 7 times, divided by 7 times 7 times 7. So if I multiply this out, the top part I get 823,543. And on the bottom, if I simplify, I get 343. Well, I know I can divide those out, and when I divide them, I get 2,401. So we've solved these before. However, tonight I'm going to show you another way to do it. And that is dividing powers with the same base. So when you have numbers, or exponents really, written with the same base, and you're going to divide them, what you can really do is subtract the exponents. So for example here, again, I showed you 7 to the 7th. I could rewrite again 7 times. All right, and then I could do 7 times 7 times 7. Now the previous way I showed you was crossing out the ones they have in common, and then you get 7 times 7 times 7 times 7, which is 2,401. Or if you take a look, I can use this new one they're talking about, this new idea. I take the numerator, which is 7 to the 7th, and I'm going to subtract the exponent. So I'm going to subtract the exponent on bottom, which is 3. And I get 7 to the, well, 7 minus 3 is 4. Well, 7 to the 4th is the same thing as 7 times 7 times 7 times 7, so you get 2,401. There you go. So either way, you get the same answer, whether you write them all out like I did in green, or if I subtract the exponents like I did in blue. So here we have A. Again, you're going to do the same idea. Subtract the powers. So if you do A, all right, my numerator, I have 4 to the 12th power, and I'm going to subtract the bottom power, which is 8, and I get 4 to the 4th power. Now 4 to the 4th power is 4 times 4 times 4 times 4, which equals 256. There we go. Now B is a little bit different because this time we don't have just numbers. We actually have variables. But it works the same way. All right, you keep the base the same and subtract out the exponents. So I want you to use the same rule and solve B. When you're all done, come back and check your answer. So go ahead and solve that one now. All right, so let's check this one. In my numerator, I have w to the 18th power, and I'm going to subtract the exponent since the bases are both w's, and I get w to the 5th power. Now here, that's just my answer because I don't know what my base is. It's just the variable w. So that's as simplified as I can put it. Now, however, we get one that looks like this. All right, 7 to the third divided by 7 to the third. Well, if I subtract out the ones here, I get 7 to the 0th power. But what does that mean? All right, what does 7 to the 0th power? Does that mean it's 0? Does it mean it's 1? What is it? Well, when you get situations like this, when the exponents in the numerator cancels out all the exponents in the denominator, what you end up having here is 1. So whenever they cross themselves out or take themselves out, you're left with 1. And I can show you why this works. Again, if I wrote this out as 7 cubed, or 7 times 7 times 7, divided by 7 times 7 times 7, and I crossed out those pairs, what we're really doing when we're crossing these out, we're saying, oh, well, we know 7's a factor. So we're dividing each one of these by 7. 7 divided by 7, though, is 1. So we're leaving a factor of 1 behind. Here, we're leaving a factor of 1. Here, we're leaving a factor of 1. And if you take a look, 1 times 1 times 1 is 1. 1 times 1 times 1 is 1. Well, look at that. You get your 1. Now, that works both for arithmetic. Anytime you get, like here, we have 3 to the 0th power. Down here in red that I'm circling, 3 to the 0th power is 1. And in algebra, a to the 0th power is still 1. So even if you have a variable there, it's 1. So now we have this one. Well, we can take a look again. Negative 12 to the 73rd power minus, well, exponent is 73. We get negative 12 to the 0th power. Well, anything to the 0th power is just 1. That's our answer. Now, the second one here is a little more complicated because we have 8 times s to the 20th power divided by 32 times s to the 20th power. So here we actually have 2 steps. We need to simplify just the numbers, or those coefficients in front of the variables, and we also have to do the variables here. So I'm going to focus on the 8 and 32 right now. I need to find a factor of both 8 and 32. And right away, I think of 4. I know 4 goes into both 8 and 32, so I'm going to divide it out. 8 divided by 4 is 2, s to the 20th. And then 32 divided by 4 is 8 times s to the 20th. Well, looking at that, I have 2 times s to the 20th divided by 8 times s to the 20th. Well, there's another factor that goes into both 2 and 8, and that's 2. So I could simplify even more. And I get 1 times s to the 20th power divided by 8 divided by 2 is 4, s to the 20th. Now I go ahead and do the exponents. All right? Now I'm going to leave this 1/4 alone. What I'm kind of doing is cutting it in half right now. I know I have 1/4, but now I need to take care of my variables. S to the 20th minus, well, same base to the same power, and we get s to the 0th, which is the same thing as 1. So here I'm going to times that 1/4 by 1, because s to the 20th divided by s to the 20th is 1. And you get anything times 1 is the other number, so 1/4. There we go. Now, however, the ones we've been working on, we've either had variables that canceled each other out or some left over on top. But sometimes we get problems where the number, larger number, is on bottom. So if we subtracted this, we get 6 cubed minus, well, 6 to the 5th, and you get 6. Well, 3 minus 5 is negative 2. What does that mean? Well, when you get ones like that, all right, you can put it as a fraction over 1, or if it says write it without a fraction bar, write it as a negative exponent. Here I have it written as a negative exponent. I have 6 to the negative 2nd power. All right, but what that really means is if we write it over a fraction, I'm going to write this out the other way we talked about. 6 times 6 times 6 divided by 6 times 6 times 6 times 6 times 6. If I do this and I cancel out the ones we have in common, again, I'm left with factors of 1. Well, I'm left with 1 times 1 times 1, which is 1. And then I'm left with 1 times 1 times 1 times 6 times 6. Well, hey, that's 1/36. These are the same answers. When you have a negative exponent, that means you write it as a fraction over 1. So you switch it so we have a factor of 1, or a number 1 at the top, and then you rewrite the exponent on bottom, but that -2 turns into a +2. So, here we go. Simplify each expression. We have 6 to the 12th divided by 6 to the 14th. And again, it doesn't matter how you do this. You could write it like that, right, and you'd get 6 to the -2nd power. But if we wanted to simplify this or write it as a fraction, you'd write it 1 over and put this on bottom now, but your exponent becomes positive. Because on the bottom again, it was actually a +2. There's 2 more 6's on bottom, 2 more here than there are up there. Now you're going to do the same thing with B. All right, go ahead and subtract those out, and when you're all done, check your answers. So go ahead and pause the video now. All right, let's check B. Again, you could rewrite this as z times z times z times z, and then on the bottom have z 15 times. Or you could write it as z to the 4th minus, well, z to the 15th. And you get, let's see, 4 minus 15, those are different. 4 is positive, 15 is negative. So I subtract them, and my 15 is negative. So this is z to the -11th power. But again, if I want to write it as a fraction, I write it 1 over, and on the bottom I put z to the +11th, because there are 11 more z's on bottom. All right, now, however, we're going to flip it. Here it says write a squared times b cubed divided by a times b to the 15th without a fraction bar. So this time they want us to just write it with negative exponents. When you do ones like these, you're going to do it the same way. You have to find the factors with the same bases. So here I have factors of a's and I have factors of b. So I have to do those separately. So in red I have a squared minus, on the bottom, I just have an a, which is really a to the 1st. So 2 minus 1 is 1. I get a to the 1st power. Now I do the same thing with b. Well, b is 3 minus 15, which is, again, they are on like symbols, so I subtract them. And 15 is negative, so it'd be b to the -12th power. So, again, I could write this as a fraction, but they don't want it written. They said without a fraction bar. So what I'm going to write is a to the 1st times, well, b to the -12. That's your answer. And again, you don't really need that 1 in there for a. If there's just one a listed, you know it's just a. So here, I would like you to try to do a, b, and c. When you're all done, come back and check your answer. Again, just do what we were doing. Write them without a fraction bar. So you're going to subtract the exponents and then just leave it that way. So go ahead and do a, b, and c. Pause me now. All right, let's check a here. Well, we have b cubed minus b to the 9th, and I get b, well, 3 minus 9. That'd be b to the -6th. All right, now we can look at b here. And we have m cubed times n squared divided by m to the 6th times n to the 8th. Well, I'm going to do the same thing. I can do the m's, do 3 minus 6. And then I could do the n's right away too, 2 minus 8. And then I solve. So we have here m, 3 minus 6 is -3. And then times n, well, 2 minus 8. Again, the symbols are not the same, so you subtract them. Or the signs are not the same, excuse me. 8 minus 2 is 6, 8's negative, so it'd be a -6. All right, and then we have c. Same idea. I write my first one. X just means x to the 1st minus 5 times y with 5 minus 3. And again, you can see I always start with the number in the numerator. I always start with the exponent in the numerator and then subtract out the number in the denominator, or the power in the denominator. So I get here, well, x to the 1 minus 5, well, 1 minus 5 is -4. And then times y, 5 minus 3, is 2. That's my answer. So that is your lesson for today. Today we looked at exponents and division. Have a great night. See you tomorrow.